Hi everyone, today in this video we are going to look at calculations involving chemical reactions. Before we do that, let us recap on the relationship between mole and mass, mole and volume. So from this diagram, mass equals to mole times molar mass, and volume equals to mole times molar volume. And 1 mole is equals to 6.02 times 10 to the power of 23 atoms, molecules, or formula units. So as we carry out our calculations later, you need to bear these two in mind. Whenever we talk about calculations involving chemical reactions, the first thing to note is the conservation of mass. According to conservation of mass, matter cannot be created or destroyed. So let's say I have 56 grams of iron reacting with 32 grams of sulfur. The product produced, iron sulfide, must be 88 grams. And when we convert all this to mole, we'll find that actually the ratio is 1 iron to 1 sulfur, producing 1 mole of iron sulfide. And that's why when we write chemical equation, after we balance the equation, in this case is 1, 1, and 1. The ratio is actually mole ratio. It is not mass ratio. And this is the basis for calculations involving chemical reactions by comparing the mole ratio. Let's look at some calculations. In this question, it's talking about magnesium undergoing combustion to produce magnesium oxide. And here we have 5.76 grams of magnesium, and we want to find the mass of magnesium oxide produced. So the first thing to recall, the ratio here is actually mole ratio. And to compare the mole ratio, first we need to find the mole. So let's find the number of mole of magnesium. To convert to mole, we divide by molar mass. And from the comparison, we say the ratio of magnesium to magnesium oxide is 1 to 1 because here is 2 to 2. And therefore, the mole of magnesium oxide is also 0.24. And from the mole, we can actually find the mass. We multiply the mole with molar mass. And lastly, we get 9.6 grams. How about oxygen? Let's look at how much oxygen we need for this chemical reaction. So by comparing the ratio of magnesium to oxygen is actually 2 to 1. Right? So once we have the ratio, we can find the number of mole of oxygen, which is 0.24 divided by 2, which is 0.12. And from the mole, we can actually find the mass as well as the volume. So let's say the mass we multiply by 32 is 3.84. And if we multiply by molar volume at room temperature and pressure, is 2.88 dN cubed. So this is an example of how we calculate for chemical reaction by comparing the mole. For the second example, the mass of the product is given. The mass of iron sulfide is 74.8 grams, and we are to find the mass of iron reacted. So it is tracing backwards to find the mass of the reactant, but the underlying concept is the same, which is to find the mole and compare the mole ratio. So to find the mole of iron sulfide, we divide by molar mass, which is 0.85 mole. Comparing the ratio 1 to 1, we can say the mole for iron is also 0.85. And to find mass, we just multiply by the molar mass, which is 56, and the answer is 47.6. Now before we go on to the next example, I would like to use a simple illustration on limiting reactant and excess reactant. So let's say a simple formula or recipe to make butter cake. The ratio of eggs to butter is 3 eggs to 1 butter, producing 1 butter cake. Right? So we have two cases. Let's say the first case is we have 6 eggs and 3 butter. And we want to ask ourselves which of these is in excess. So we can ask, for 6 eggs, I need just 2 butter. And in this case, I have 3. So that means the butter is in excess. And then now we want to ask ourselves, how many butter cakes can we make? We always use the limiting reactant to determine, not the excess. So 6 eggs will actually produce 2 cakes. Very simple. Following the second example, if let's say I have 15 eggs and 4 butter, let's work out again. For 15 eggs, I actually need 5 butter. So I do not have enough butter. So butter is the limiting reactant in this case. So we use this to determine how many cakes we can make. So the ratio is actually 1 to 1, so that's actually 4 cakes. Why I'm using this illustration? Because it has to do with our mole comparison when it comes to chemical reaction. And we will have one reactant usually is in excess, the other one is in limiting. And in chemistry, we always use the limiting reactant to carry out our calculations. So let's look at this example. Potassium reacts with oxygen to form potassium oxide. We want to find the mass of potassium oxide. So very quickly, we find the mole of each of these reactants. So we will get 0.8 mole for potassium, 0.2 mole for oxygen, and we can see that this ratio is the same, 4 to 1, 0.8 to 0.2, and the number of mole of K2O is 2 to 1 as compared to potassium. We can find the mole, and then lastly we find the mass. By multiplying by molar mass, we get 37.6. So this case, the mole is according to the ratio given in the equation. For the second example, now we have a different mass of oxygen. And according to the calculations just now, 0.8 mole requires 0.2 mole of oxygen. But in this case, if we use this gram to find, we will find that there's actually 0.4 mole of oxygen. So that means oxygen is in excess. And we do not use this for calculation. If this is in excess, that means potassium is the limiting reactant. And therefore, we will still use this 0.8 mole as a basis for calculation. So the answer for K2O is still the same. So as a conclusion, for calculations involving chemical reaction, we are comparing the mole ratio as according to the chemical equation, and we can actually find the mass of product when we have the mass of the reactant. We can also find the mass of the reactant when we have the mass of the product. So that's all for today's lesson.